Everybody, this is question 20.17, Brown, LeMay, and Burston. This is a good question because a lot of the formulas that you use in this unit deal with making sure that you count the correct number of electrons being transferred. So in this case, we have a whole bunch of reactions, well, 3. I wouldn't necessarily call that a whole bunch, but and we have to identify, based on those reactions, how many electrons are being how many electrons are changing, okay? And so that's what it's saying here. Undergo changes in oxidation number and the magnitude. The magnitude says just put a number to it. So here is iodine for part A, okay? Iodine here is 0. Remember, elements are always have a oxidation state of 0. And here, let's keep in mind that oxygen is 2 minus. So that's good. So that means that iodine is going to go from 5 plus to 0. Okay. And now, carbon is the thing that's going to be oxidized. This is being reduced. So carbon is going from a, let's see here, this is 2 minus, so that's a 2 plus. So carbon is going from a 2 plus to a, let's see, that's going to be a 4 plus. Now, so this is 5 to 0. That's 5 electrons changing, but then this is only 2 electrons changing. So part of our balancing says that we need to make sure that the number of electrons that is being transferred is the same. So it's not just 5 and it's not just 2. Okay? If we look, we want 5 and 2 to be equal, so the least common multiple between 5 and 2 is 10. So the quantity of electrons being transferred is 10. And we can see here, because how many iodines do we have on each side? It's balanced. So how many iodines is that? It's 2. Okay, so 2 times 5 is 10. And then same thing with the carbons. The carbons have a, they have a, there's 5 of them, a coefficient of 5, and 5 times 2 is 10. Okay, so now we do the same thing here. Okay, let's keep in mind all our rules. So there's mercury, mercury is 0, and there's nitrogen, nitrogen is 0. So those are probably our 2 things that are going to change. So for part B has mercury, and mercury is going from a 2 plus down to a 0. So that's the thing that's being reduced. And then nitrogen, let's see, it's going to a 0. Nitrogen is going to a 0. And then but nitrogen here, let's see, that's 1 plus, because it's going to stay the same there. So this must be 2 minus. So now this is going, and that's being oxidized. The charge is going up. It's losing electrons. So, okay, so how many electrons being transferred? This is 2 electrons. This is 2 electrons. So now the transfer of electrons is happening, so the number of electrons is 2. Okay, so I think that that's the magnitude of the change there. Okay, okay, next. Okay, what can I do? So this is a 0. So over here, let's see, for part C, let's start with sulfur. I always look for the elements, because the elements always are 0. And so this sulfur is a 2 minus going to a 0. So that thing is being oxidized. Now the thing that's being reduced, I can probably guess, is going to be the nitrogen. Okay, and nitrogen is going from 5 plus to 2 plus. So nitrogen is going from 5 plus to 2 plus. And so sure enough, that's being reduced. So this is 2 electrons being changed. This is 3 electrons being exchanged. What's the least common multiple between the 2? And that's a 6. And that can be highlighted because now how many, what's the coefficient there? Okay, what's the coefficient there? 3 and 2. So that's that's the magnitude of the number of electrons that are changing. Okay, so that shows you how to kind of calculate the number of electrons being transferred for use maybe later on in some of the formulas that we have. Okay, have a great day.